Assalamu alaikum, dear students. Yesterday we discussed the slope, how to find the slope of line when it passes through two given or two fixed points. Now today we shall discuss the angle between the two lines in terms of slopes and what is the condition for parallelism and perpendicularity of these two lines in terms of the slopes. Now let L1 and L2 be two non-vertical lines. Here they should be non-vertical because if they are vertical lines means the angle of inclinations of these two L1 and L2 lines is 90. When it is 90, so we cannot define their slopes, which implies that they should be non-vertical lines. Let m1 and m2 be their slopes and theta 1 and theta 2 be the angle of inclinations of these two lines respectively. Now suppose these two lines are parallel. When they are parallel means the angle of inclination of these two lines is same, means theta 1 or theta 2 equals to theta 1. Hence tan of theta 2 equals to tan of theta 1, but tan of theta 1 is m1 means slope by definition, and m2 equals to tan of theta 2 slope of line second. Hence m1 equals to m2 when these two lines are parallel. Conversely, now suppose their slopes are equal, means m1 equals to m2, which implies that tan of theta 1 equals to tan of theta 2 by definition. Now here this theta 1 and theta 2 are the angle of inclinations of these two lines, and you know that the angle of inclination of any line lies between 0 and 180, and in this interval 0 and 180, this tan theta is 1 function. So by definition of 1 function, if tan of theta 1 equals to tan of theta 2 implies that theta 1 equals to theta 2, which implies that their angle of inclinations are same. When they are same implies that these lines are parallel. So this means that two lines are parallel if and only if m1 equals to m2, that is line is l1 is parallel to l2 if m1 equals to m2, and if m1 equals to m2 implies lines are parallel. This arrow, this is called as if and only if, and we simply write IFF for this symbol. This is called as the John Paul's symbol. This means that lines are parallel implies m1 equals to m2, and if m1 equals to m2 implies that lines are parallel. So this is the necessary and sufficient condition for two lines to be parallel. Now if we consider the case when they are perpendicular, let us assume that L1 and L2 be two lines with slope m1 and with slope m2, while as theta 1 and theta 2 be their angle of inclinations. Suppose these two lines are perpendicular, means L1 perpendicular to L2, which implies that these two lines actually L1 and L2 intersect at point, suppose this point C, while as the angle between them is 90. Now in this triangle ABC, AB, sum of the angles of triangle is 180, which implies that angle A plus theta 1, where angle B is theta 1 because it is angle of inclination of line L1, plus 90. Here this angle C is 90, which implies that this is 180. But this angle A is here 180 minus theta 2, because straight angle is 180. Hence minus theta 2 plus theta 1 equals to 90, or simply theta 2 equals to theta 1 plus 90. Now this is possible only when tan of theta 2 equals to tan of theta 1 plus 90. But tan of 90 plus theta equals to cot minus cot, which implies that this is minus cot theta 1, or simply tan of theta 2 equals to minus tan minus 1 upon tan of theta 1. But theta 2 is m2, theta 1 is m1, which implies that it is m2 equals to minus 1 upon m1, or m1 equals to m1 into m2 is minus 1. So this means that two lines are perpendicular if and only if the product of their slopes is minus 1. So this means that this condition is necessary and sufficient condition for two lines to be perpendicular. Now, how to find the angle between the two lines if their slopes are given? Now, you know that in previous we discussed what is the condition between two parallel lines and what is the condition between two perpendicular lines. Now, we will consider the case when these two lines intersect each other, suppose at point O, but not orthogonally, means not perpendicularly. Now let us assume that L1 and L2 be two lines with slope m1 equals to tan of theta 1 with slope m2 equals to tan of theta 2, such that these two lines intersect each other at point O. Now when two lines intersect but not perpendicularly, which implies that they will form two pair of vertically opposite angles. Here alpha equals to alpha because vertically opposite angle, and this angle equals to this angle, that is beta equals to beta, because they are any two vertically opposite angles are equal. So this means that here when these two lines intersect at point O, they forms two pair of vertically opposite angles. One is alpha, second one is beta. Now here this alpha is acute angle, while as this beta is obtuse angle. Now in triangle A, B and triangle O, sorry, here it is O, not C. Sum of the angles of triangle is pi, means 180. Here this angle A is theta 1. This angle O is alpha because vertically opposite angle. And this angle B is pi minus theta 2 because L2 is the line whose slope is m2 with angle of inclination equals to theta 2, which implies that this angle is theta 2, hence angle B is here pi minus theta 2. So substituting in this, we simply get alpha equals to theta 2 minus theta 1, where this alpha is the acute angle between these two lines. Hence tan of alpha equals to tan of theta 2 minus theta 1. Now using tan of A minus B formula here, it is simply tan theta 2 minus tan of theta 1 upon 1 plus tan theta 2 into tan theta 1, or m2 minus m1 upon 1 plus m1 m2. Now here these two lines do not intersect orthogonally, means perpendicularly, which implies that this alpha is not equals to 90. When this angle is not equals to 90, which implies that m1 into m2 is not equals to minus 1, because necessary and sufficient condition for two lines to be orthogonal is that m1 into m2 is minus 1. Now which implies that this number is here defined. Hence this alpha, tan of alpha equals to m2 minus m1 upon 1 plus m1 m2. So this means that the acute angle between these two lines is m2 minus m1 upon 1 plus m1 m2. Now how to find obtuse angle between two lines? Now beta is obtuse and its measure is pi minus alpha, because straight angle is pi, or simply we can say that linear pair of angles, sum of linear pair of angles is 180. Now which implies that beta equals to pi minus alpha, or tan of beta equals to tan of pi minus alpha, which is minus tan alpha, or simply equals to tan alpha, is where alpha is acute angle, it is m2 minus m1 upon 1 plus m1 m2. Hence tan of beta equals to minus times m2 minus m1 upon 1 plus m1 m2. Here this is obtuse angle, and you know that obtuse angle means angle in second quadrant, and in second quadrant tan theta is negative, which implies that this is here negative and is the obtuse angle. So this means that simply if we have to find the acute angle between the two lines with slopes m1 and m2, then tan of alpha equals to, where alpha is the acute angle, it is simply modulus of, means positive value of m2 minus m1 upon 1 plus m1 m2, while as if we have to find the obtuse angle, which is beta, that simply equals to tan of beta equals to minus and minus, or simply the negative number of m2 minus m1 upon 1 plus m1 m2, because when it is beta is obtuse, means in second quadrant value is negative, that is why we must take this value to be negative. So this is the obtuse angle, while as this is the acute angle between the two lines whose slopes is m1 and m2. Inshallah, in tomorrow video lecture we will use these three concepts while solving the exercise 5 in this exercise first. So thank you.